Okay, so let's work on evaluating a 3 by 3 determinant. So here's a matrix given to us. How do we evaluate a 3 by 3 determinant? So we write the without brackets. Now there are two different methods of evaluating a 3 by 3 determinant. I'm just going to show you the one that I think is the easier method. You can also read and take a look at the other method that is given to you in the book, which is on page 595, 596. And you can also do that, but I don't recommend it because I think it's just too much. Anyways, so when you want to evaluate a 3 by 3 determinant, you copy the first two columns right on the right hand side of the determinant like that. Okay, and then you evaluate this diagonal, this diagonal, and this diagonal. Okay, so let's do that first. So we have 2 times -1 times 4, so that's -2 times 4, that's an 8. Plus, you add these, the more zeros you have, the luckier you are, because 1 times 0 times -2 is a 0, plus -3 times 1 times 1, that's -3. Okay? Minus, you open up a parentheses, then you evaluate these diagonals that I'm showing you in red. Okay, so -2 times -1 is +2 times -3 is -6, plus 1 times 0 times 2 is a 0, plus 4 times 1 times 1, and that's a 4. Okay, so these diagonals multiply the elements in each diagonal, add them up, minus these diagonals, add them up. So this gives you 8 minus 3, that is 5, and this gives you a -2, whether you have a minus, that's 2, so that gives you the final answer of 4. I'm sorry, 3. Okay. So that's -2. Yep. Okay, very good. Are we okay with that? Okie dokie. All right, so let's try another. Now, how do we use these in our in solving equations? So let's see if I move this and show you the book on page 606. Page 606. You see at the bottom of page 606, if you have a system of two linear equations, this is the way we can use determinants. It's called the Cramer's rule. Cramer's rule. Okay, so you set up a d of x, a determinant for x. Actually, you set up a determinant d, which is all these coefficients, and then a d of x, which you replace the x coefficients with these constants over that, and that gives you the x value, and then the d of y on the top. You notice these coefficients are replaced by these constants and over the d, and that gives you a y. Let me give you an example so it will be easier. That could have been a little bit confusing. And also by a 3 by 3 for 3 by 3 determinants given to you on top of page 608. If you have, I'm sorry, a system of 3 equations, if you want to do that, then you have to solve for x, y, and z, and the setup is given to you on that. I'm going to do one example of each. So let's say I have this system. Oh, actually, let me see, on page 621. Let's say I have this system here. X negative 2y equals 6, and 4x minus 3y equals 4. Okay, so how do we do Kramer's rule for this one? Okay, so first we set up this determinant, we just call it D, and that's these coefficients. So there's a 1 here, and then there's a 4. So the coefficients of x form the first column, and then the coefficients of y forms the second column. So we have a 2 by 2 determinant, and so 1 times negative 3 is negative 3 minus negative 8, and that gives you positive 8 minus 3, that gives you a 5. Okay. Then I want to evaluate d of x. So what does that mean? That means you take these numbers out and replace it by these constants. So 6, 4, and then the y values stay the same. I mean, the coefficients for the y stays the same. Now evaluate that determinant. So that's negative 18 minus negative 8, which gives you positive 8. That gives you a negative 10, correct? And then you evaluate the d sub y, where the coefficients in front of the y are replaced by these constants over here. So I'm going to put 6 and 4 here, and I'm going to keep the coefficients of x the way they were. So 1 times 4 is 4 minus 24, and that gives you a negative 20. Okay, so d of x, d of y. Now how do I solve for x and y? X will be obtained by dividing the determinant d of x over d. What was d of x? Negative 10 over d, which is 5. So my x value is negative 2. The y value is determined by d of y divided by d. What is d of y? Negative 20. What is d? 5. So my y value is negative 4. Therefore, I found my solution to the system is negative 2, comma, negative 4. We're good? Okay, stop here and show you the next example in the next part.